Hi, I'm Lee Teschler, Executive Editor of Design World magazine.
And I'm Michelle DiFrangia, Assistant Editor of Design World magazine. We are continuing our series of teardowns where we take perfectly good LED light bulbs and turn them into piles of junk for your entertainment. Today we have an LED light bulb from Feit Electric, which is made in China. I understand the orientation of the LEDs on this one is a little bit weird, Lee.
Yes, I'd go so far as to say the bulb from Feit Electric had the oddest orientation for LEDs of any of the 5 we examined. When you cut the plastic dome off, you find that there's a 1 7/8 inch diameter plate onto which the 36 LEDs mount. But the LEDs are partly hidden in the assembled bulb by a circular plastic piece with a 1 inch diameter hole in the middle. This piece mounts over top of the LED plate. So a look at the assembled bulb provides a view of the plastic piece and just 5 of the LEDs visible on the center of the plate below the hole in its middle.
So the plastic blocks the light from all but 5 LEDs. Why would they do something like that?
Well, I'm flummoxed by this. I'm at a loss as to why Feit installed the plastic piece over top most of its LEDs. The piece blocks most of the light they emit. We have no way of quantifying the amount of light getting through the plastic, but informal tests here indicate little of it gets through. So the vast majority of the emitted lumens come from the 5 LEDs in the center of the plate. Now, if you're viewing this video, another possibility you might wonder about is whether all 36 LEDs are powered on when the bulb is plugged in. Well, we followed the traces on the LED plate and all the LEDs seem to be in series with each other. In other words, all of them seem to be on, even the LEDs under the plastic disc when the bulb is plugged in.
But if the plastic thing blocks a lot of the light, does this bulb still give off as much light as, say, a 60-watt incandescent bulb?
Weirdly, yes. Before we started cutting apart these bulbs with a hacksaw, we powered them all up and put them side by side. This one seemed to put out as much light as the other 4 from other manufacturers. There were differences in the color temperature of the 5 bulbs, but they all seemed to put out about the same amount of light. And that stands to reason, because before you can advertise your LED bulb as being the equivalent of a 60-watt incandescent, its output has to be certified. The way the output of a light bulb is certified is by putting it in a special chamber and using a sensor to measure the bulb output in lumens. The output has to measure between 800 and 900 lumens to be equivalent to a 60-watt bulb. Despite blocking a little less than 85% of its light output, the Feit bulb puts out the correct amount of lumens for this.
Well, I guess the reason behind this blocking gizmo is just one of life's little mysteries. What else did we find in this LED bulb?
The rest of the bulb's mechanical design is less mystifying. The LED plate mounts to the top of a hefty 3.8-ounce cast metal heatsink via 3 screws. The heatsink serves as the main body of the bulb. And I should also say that of the 5 LED bulbs we tore down, this one had the heaviest heatsink. It is actually about 37% heavier than the next heaviest heatsink. The AC-DC converter circuitry fits in a plastic cylinder that slides into the base of the heatsink and attaches to it with 2 screws. This is actually the second LED bulb we found that used a plastic case for the circuit board this way. The electronics is potted into this plastic cylinder that serves as its housing. The potting material is rubber-like stuff and is pretty extensive, filling the cylinder.
Some other LED bulbs we've seen have used potting material just like this one.
Right. And in the other bulbs that coated the board with this stuff, we weren't entirely sure why. In the case of the Feit bulb, it's clear why the rubber-like potting stuff is there. It doubles as a structural element, supporting the screw base of the bulb and the contact foot. Once you get the rubber stuff off the circuit board, you see that the circuit board holding the electronics is 2-sided and extends back nearly to the foot of the bulb base. The negative lead to the board is held to the metal screw threads by the potting material. 2 wires run from the board to the LED plate and seem to be hand soldered there. The board itself is reflow soldered.
Potting material like that doesn't make it easy to figure out what's on the circuit board.
Right. The potting material did indeed obscure some of the details on the PCB. Once we cut and milled it off, we found 2 power MOSFETs, a diode bridge chip, 5 large caps, a transformer, and at least 22 discrete components comprised of resistors, small caps, and diodes. The input bridge rectifier seems to be protected with a physistor. The main chip is an SSL2103T LED driver from NXP Semiconductors. The SSL2103 is basically a flyback converter that operates in combination with a phase-cut dimmer circuit directly from the rectified mains. It implements dimming via integrated circuitry that optimizes dimming through resistive bleeder switching.
Bleeder switching, that sounds like it relates to hemophilia.
Actually, it relates to when there's a light dimmer that uses a triac, as are often used for dimming ordinary incandescent lights. The bleeder circuit is, in fact, a current source designed to draw a fixed current from the triac in the dimmer. This current keeps the triac energized from when it fires on to the end of the AC cycle, even when the load draws no current. If you don't keep that triac on until the end of the AC cycle in which it fires, you can get a flickering in the LED light during dimming, which is pretty annoying.
Well, that's interesting. What else did you find?
Though potting material obscures some of the connection details, the circuit seems to be close to that of reference designs NXP provides for the chip. The mains voltage is rectified, buffered, and filtered in the input section and connected to the primary winding of a transformer. Transferred energy is stored in a capacitor and filtered before driving the LED chain. The circuit board also includes two power MOSFETs. One seems to be part of a dimming circuit that divides and filters the mains rectified voltage to provide an input for the generation of the dimming curve. A bleeder drive output from the NXP chip drives the MOSFET to switch bleeder resistors that are involved in the dimming function. The other MOSFET is the main switch for the flyback transformer. There's also a buffer circuit consisting of two capacitors and an inductor. The circuit stores energy to ensure the converter can transfer power continuously to the LED chain despite any mains power fluctuations. It also filters ripple current generated by the converter to keep down any mains conducted emissions. Finally, another portion of the circuit consists of a capacitor, rectifier diode, peak current limiting resistor, and a protection Zener diode, and it's used to generate an external V sub CC supply to the IC.
Well, since this one is the heaviest of the LED bulbs we've looked at, it sure makes a good paperweight if it ever gives out. If you want to see the rest of our LED bulb teardowns, check them out at designworldonline.com.